Hello everyone, welcome back to the channel. In today's video, we are going to answer one of the most frequently asked Databricks interview question. Like if Delta Lake stores data as a Parquet file, why do companies prefer Delta Lake table over plain Parquet files? At first, this question can be confusing because both involves Parquet files only, but at the end of the video, you will understand the major benefits of Delta Lake. Okay, let's start the video. First, we will understand what is Parquet file. Okay, Parquet is a columnar file format designed to store data efficiently for analytical workloads. Like instead of storing your data row by row like a CSV file, Parquet stores data column by column. This makes it much faster for analytics because Spark only reads the columns required for your query. And actually, why we need to use this Parquet? There are four major benefits. The first one is columnar storage format. Since data is stored in column by column, Sparks reads only the required columns. Instead of entire your data set, it pick only the required columns for your processing. This improves query performance significantly. And the next one is high compression. Parquet automatically compress your data. As a result, it uses less storage space and helps reduce cloud storage cost. And the third one is data skipping. It will quickly retrieve only necessary columns as I mentioned. So it will minimizes the data read for your queries and the predictive push down support. All this will be beneficial for using this Parquet file format. And coming to faster query performance, because it reads less data and uses compressions, Parquet performs much faster than formats like CSV or other formats, the row columnar row based formats. It was like a benefit for us to use the Parquet file columnar format. Parquet is designed especially to efficiently handle millions or even billions of records, making it ideal for modern data engineering workloads. Is Parquet enough? If Parquet is already fast and efficient, why don't companies simply use this Parquet, right? So this answer we will see at the end of the video. There are some limitations for this Parquet file format also. I will be covering in the end of the video. Now coming to what is Delta Lake. Delta Lake is a table format and storage layer built on top of a Parquet file format. Whatever we have just now discussed, on top of that Parquet files, the Delta Lake table has been created. So, but along with those Parquet files, it maintains a transaction log called underscore delta log. Okay, this transaction log keeps track of every change made to the table. So why do companies prefer Delta Lake means? Now let's understand why each and every concept we will understand. The first one is ACID transactions. The Delta Lake supports this ACID transaction. Like if multiple users are writing data at the same time, like we have some table, we have some orders table. If multiple stores are writing the data into the same orders table, it will cause some consistent data inconsistency, right? So at that time, it will allow this ACID transaction. Only one user can write the data to the table. So if multiple users are writing data at the same time, Delta Lake guarantees data consistency. Like it can support like this update, delete, merge. Unlike plain Parquet file format, Delta Lake supports SQL operations such as update, delete, and merge without manually rewriting the entire file. And the schema enforcement. If someone tries to load data with an incorrect schema, Delta Lake prevents bad data from entering into your table. You can evaluate your schema. You can use some merge schema is equal to true. All these features enable you to load your data without dropping or without breaking your production pipeline. And the time travel. If someone accidentally deleted your data from your Delta table, remember the data has been lost, but in Delta Lake we have this time travel feature. You can retrieve your lost data from certain retention period they are allowing. Like you can query your deleted data and you can restore your data from the time travel feature. Coming to the scalable metadata, it efficiently handles large scale metadata and reduces the overhead from many small files. Like if we have multiple small files, we have some best features in Delta Lake like optimize and vacuum. Like the optimize command, what it will do, if you have multiple small files, it will combine and create one large file, and it is efficient for processing a huge amount of data by the Spark engine. So these are the major benefits of Delta Lake format. So now let's see the major difference. Like, so if you see fast reads, both are supporting Parquet and Delta Lake. Compressed storage, both are supporting. Columnar format, yes. But update, delete, merge, as I said, these three operations cannot be supported by Parquet file. And the ACID transactions also, no. Time travel feature is also not available. Reliable concurrent writes, no. Schema enforcement, no. So all these benefits are providing by the Delta Lake. So why companies use this? We have clear understanding. Now let me give you one sample example. Like as I said, let's take an e-commerce example. Suppose we have an orders table. I have already covered. For example, if every minute new orders are creating, existing orders are canceling, or delivery status are updated, or customer addresses are they are making some changes to their address. So if we are using only Parquet file, handling all these changes, updates becomes very difficult because Parquet isn't designed for transactional operations. With the Delta Lake, these operations become simple using this update, delete, merge while maintaining data consistency and reliability. I hope this video helped you clearly understand the difference between Parquet and Delta Lake. If you found this explanation useful, don't forget to like the video, subscribe to the channel, and share it with your friends preparing for Databricks interview. In the next video, we will continue with another important Databricks interview question. Thank you.